and I want to rehash a few things, but I'm going to re-go through Turtle, and today we're going to move on to making our own OOP program really quickly. Now, before we get into rehashing anything, I want to quickly draw attention to this thing. It looks like a broken screenshot, apparently. Such a cool effect. Absolutely love it. All created through code, which is really nice. So what I'm going to quickly do, everybody, is we're going to rehash how to use Turtle. We're going to rehash why Turtle is an object-oriented program. And then we are going to jump straight into making our own shapes one after you guys have had a play with Turtle. You will need your books. So if you want to grab them out while I'm getting set up, I would suggest you do that now, please, guys. Earballs and your attention just for a little bit. So the way I introduced OOP programming, or object-oriented paradigm programming, is through Turtle. And the main reason is because Turtle is amazing. You can draw all sorts of crazy shapes in only a couple lines of code. So if you have a look up here for me, everybody, when we wrote our Turtle program, the first thing we did was a from Turtle import star. Who remembers what that line 1 performs?
Imports all the code from the Turtle file that's already been created.
Absolutely spot on. So Turtle's already been created, like Ben said, and this star says, give me all the good code, everything, okay? And then on line 3 there on that example, can anyone tell me what crush equals Turtle brackets means? Perchance, Dobby, do you want to jump into this one?
Crush. Oh, that's the variable that is storing value.
Yes. Now, who remembers the terminology that we used last time? There's a word that starts with the letter C and a word that starts with the letter O. I'm going to give Ben one more.
Object and other one is something else.
Class. Yes. So, just quickly, everybody, this is really important because I want you to walk away knowing these terms. Okay, on the left-hand side we have crush, which Dobby very correctly said is a variable, but in this time we actually give it a different name. We call this an object, okay? And objects are created based on a class, okay? And the class here is Turtle. Is everyone okay with that somewhat? Alrighty. Now, what's the difference between it? The difference is class, Turtle, has all the code. It has all the variables. It has everything to do all the work. And then the object we make, in this case crush, we can do some work with that class. Okay, that's how we interact with the code. It's how we interact with the data. So how the hell do we use Turtle? We're going to quickly revise it. The first thing you have to do is install it because it is a package of code someone else has written. So if I press F1 on the keyboard, it brings up this menu. You click on Create Terminal. Make sure it says Python on it. And the first thing you're going to do is type in -m pip install Turtle. Only do this if you have not already. Hit enter, and then hopefully it comes up with downloading, and it might give you a few warnings or errors, but for some reason it seems to work, even if there are errors. All right, and we're ready to go. Now, the next thing I'm going to get you to do is make a brand new file. So up here, I've already made a new folder called Turtle. It's empty. So I'm going to click on the little new file button, and I'm going to call this turtle1.py. Who remembers why we don't just call it Turtle? Why that?
Because it overrides the library.
It overrides the library of code. Because the library is called Turtle, if you name your file Turtle, Python has no idea which one's which. And it always picks your file. So first line of code, if you ever want to use Turtle, or you ever want to use a library of code or a package, you type the name in, import star. Okay, and that will take all the code from that library, jam it into your application. Now let's make our object. Who remembers again, why did I call it crush?
Nemo.
Crush is the turtle from Nemo. Crush equals capital T for turtle and brackets. We now have an object called crush based on the class turtle. Now we can start doing things. What things can we do? Well, if you type in crush and put a dot, you literally have every single bit of code that it can perform. Now everybody, can you have a look? This is something I didn't teach you last time because I was sort of rushing it a little bit. Can everyone see those icons on the left-hand side next to all the words? If it's got a purple box or a blue box, that is a method, also known as a function. Okay, so for example, forward is a function. So that means after the word forward, you must put brackets. Everyone okay with that? Cool. Let me do that again. If it comes up with this little page looking thing, that's a variable, and you'd have to put an equals after it. Okay, am I going to put a value? No, I'm not. Okay, let's just do crush.color equals red. Okay, I'll do lowercase because that's better for this. Then we'll do crush.pen down, brackets again because it's purple, and then forward. That's really laggy today, isn't it? Wow. And then we put input at the bottom. Why do we put the word input at the bottom, guys and girls? Ben?
To make sure that it
Attention
flows
students,
off.
Katie Kelly to the front
I don't
office.
think anyone heard that, but you were right on the money.
Katie Kelly to the front office.
So what Ben said is the input at the bottom there, we'll keep it on the screen. If you don't have input, it just closes straight away. So we hit play, literally it'll follow these 3 steps. Okay, it'll just, there you go, bam. He turns red, he puts his pen down, and he draws a line moving forward. Okay, why did he move forward that much?
Because you put it in 100
What do you think the 100 represents?
pixels.
Bingo, pixels. So guys and gals, if you were away on Monday, you've got a little bit of work to do. You've got to try this script and then this script. There's 2 of them. For the people who were here, it's time to practice. Go nuts, have fun. So let's jump back into it, guys. Thanks, guys. Still waiting for a couple. All right, boys and girls, get those pens at the ready and your books at the ready because we've got a tiny bit of theory to write down. It won't be huge, but before we go into it, I want to quickly give something to you. I'm going to give you a scenario. Do not write this bit down. Very soon you'll be writing. But we want to create our own library of code that people can use. I want to create a shape calculator whereby Adrian can simply say, I want a rectangle, it's this size, what's the area, mate? And I will tell him straight off the bat. And then we're going to go as far as drawing it on the screen as well with the correct sizing, etc. Okay? But to start with, our OOP module is going to consist of a very basic shape calculator that calculates the area and the perimeter of your shape and will draw one to the terminal to begin with. Later on, we'll go nuts. We'll add a lot more to it. Okay. But the first thing I need to teach you guys and gals is, well, how do you plan these things? We have a diagram for everything in software, yeah? We have a diagram for algorithms, flowcharts. We have a diagram to organize our functions in our code, our structure chart. We have a diagram to organize our variables. That's our data dictionary. And we have one to organize our interface. That was our storyboards. So we have one to organize our classes, also known as a UML diagram, a Universal Model Language diagram. Get writing, boys and girls. I want you to draw this up in your books, and very soon we're going to label it. So put it in the middle of your page. And we're going to put little arrows pointing to all the little bits of this diagram to show you what's going on. But basically the way it works is at the tippity top where it says class, that is literally the name of the class you're going to make. If we were making turtle, the word turtle, guys and gals, would appear in the top. Underneath that where it says fields, that's where we put our attributes, also known as your variables. Okay? So for turtle, that'd be things like the color, the pen size, okay, the angle that they're facing. And then at the bottom, method is also a word for functions. So that'd be things like forward, left, right, pen down. Those are your actions that your class can perform. Okay, so I'll bring up this lovely little thing. There's all your little labels. Okay, so you guys and gals, can you please draw this up in your books under the heading of UML diagram, please. So just quickly, 2 little things that I didn't explain to everybody is these pluses on the side can either be a plus, a minus, or a hash. And a hashtag, a hash. Okay, and they actually represent who can use them, essentially. If it's got a plus next to it, everybody in the entire world is allowed to use it. If it's got a minus, no one. But the class itself can use it. And usually that's for like, maybe you've got to encrypt a password or something like that. If you want something really secure to be kept more secure, you would use a private or a minus symbol. And then the last one, protected, means it hides it from the world unless they're a sibling. And we'll get to the idea of siblings later, okay? We'll talk about it. If you remember the word inheritance that we talked about in the first lesson, that's what I'm referring to there with sibling. Okay, and the only other thing I didn't explain is where it says field and then colon type. Type is literally, what is the data type? Integer, string, float, Boolean, date time. all those kind of things. Yeah, Val?
We'll be learning how to kill children.
No.
Collapse them.
Gets us as well. Where it says fields, let's say we were modeling a person in our UML diagram. Okay, I would replace the class name up here with just the word person. And then the first field is, okay, what data do we want to remember about a person? So what's the most obvious thing, Sam?
Name.
Their name. So things like first name and last name. Okay, what else might be important about a person?
Age.
Age is a great one. What else?
Eye color.
Eye colour, very nice. Anything else we can think of?
Height.
Height, love it.
Physical attributes.
Physical attributes, break them down too though.
Feet size.
Ooh, V-ties, yeah.
That's very
Pardon?
specific.
Date of birth.
Date of birth, love it.
Big.
All right, so you guys have got that. What about methods, okay? What things can people do? It's a weird, that's a very generic question, isn't it? But
Eat.
they can eat. Awesome, that is good. That's a method.
Drink.
They can drink, hopefully water and hydrating beverages, yes?
They can
What
go
else?
to the club after a breakup and have sorrow.
And have sorrow. That just sounds like the worst meal you can eat.
See.
They can see. All right. I'm actually going to jump into my proper example now, guys and gals. So, here is my example I'd like you to draw down. But before you do, let me talk you through it. Have a look at the top. Okay, you guys basically hit the nail on the head for all those functions. Val, eyes up. Person consists of a first name, a last name, and a date of birth. Everyone's cool with that, aren't they? It's attributes about a person, okay? And then at the bottom, we have two functions. The first one, get their full name, and then get their age. So how would I get their full name? Who can tell me how I'd do that based on the attributes up here? That'll go.
You combine the two.
Simple as that. You combine the two names, you've got their full name. What about date of birth? What can we do there to get someone's age from their date of birth?
Minus the current years from the ones that they were born in, like the
Yep.
year they were born in minus that from the current year.
Absolutely spot on. Yeah, it'll give us it won't give us the exact age because they might, it might be later in the year, but it will tell us what age they are this year. So that is absolutely spot on. Now, what the hell do you think's going on down the bottom though, guys and gals? So we've got the person at the top, and they've got a name, they've got a date of birth, they've got a full name function and an age function. What's all this down here? What do you reckon's going on there? Ah, there it is, subclass. That's actually a great use of the word. This up here, boys and girls, we call that a super class, and we call down is not subclass, but it is a child class. Okay? But I love that you said sub because it was so goddamn close to the final thing. So, everybody, coming back to the terminology that we wrote down in our books, one of those terms was inheritance. The idea that we can have a child class that inherits everything from the parent or the superclass. In this case, student down here is inheriting everything from person. So that means when we make a student, they don't just have a finish year, they've got a finish year, a first name, a last name, and a date of birth as well. Does that make sense? Or not? Cool, and that means they've still got get full name, get age, and it's also got their year down the bottom. So get year is in like what year are you in? Year 11, year 12, things like that. Same thing, have a look over there for the teacher for me. What attribute does the teacher class, Sam, introduce? In
Class it introduces what class they're in and what classes they have.
what classes they have? Absolutely spot on. It says string after it with square brackets. Who can tell me what that might indicate? A list of strings. Spot on. And then we've got one function added to the bottom of it. Brody, what's that function for our teacher? Or our method?
Add class.
Add class. What do you think the name in the brackets represents?
The name of the class.
Spot on, the name of the class. That's it. So guys and girls, this is how you can set up classes. And the great thing is you can create a super class at the top with most of everything that you need. And then you make little child classes that have like the little extra bits on top. So what we're going to do when we do our shape calculator, we're going to make a super class called shape with 90% of the code in it. And then we're going to make other little child ones called rectangle, circle, triangle to add the little bits for those classes. Now, guess what I'm going to get you to do, guys? Draw your example, please. Quick explanation of what the hell's going on here. So here's our class called name. So obviously later on we're going to make a class called shape and we'll fill it with some good code. There's how you make your attributes or your variables in a class, and there's how you make your individual functions. Now when you set up functions in a class, you must have self in the brackets to start with. And as I said, this will make more sense when we start using it. Now I want to introduce one more thing for you all. And this is going to look ugly, and I'm going to put it between attribute 3 and method 1. We're going to put def again, and I'm going to put you a double underscore init double underscore bracket self. It is but ugly, but by God it's important. So in terms of moving on, guys, I won't explain what this function is for just yet until we start using them properly, because this one's a little bit confusing. Just know that the double underscores at the front and the back are like built-in things that Python uses. Okay? So is everyone cool with that so far? That's what it looks like. Let's set up our person class that we just created a UML diagram for. So can everyone make a new file for me? I'm going to call this one personclass.py. Let's set it up. So let's wait until everyone's got that one. Sweet. So what is the first word we're going to put down, Jensen? At the top of the file? What's the first word we're going to put in here? Class. Okay, then the name of the class, the top one. What was the name of our big class at the top? Wasn't student, wasn't teacher. Person, thank you. What attributes did our person have? First name. And what data type was it? String. So what should I put after the equals to make it a string? Double quotes. Last name equals double quotes as well. And then what was the third attribute our person had? Date of birth. And what data type was that? It was a date time. Okay, so there's how we set up our attributes, boys and girls, for our person class. Question for you, why have I got an error on line 4?
Because you haven't activated datetime yet.
Bingo. So let's import, or from datetime import star. Just like we did literally in the last program. All right, I'll pause there for a sec. So moving along, guys and gals, let's do the two methods that were in our person class. So there was get full name and there was get age. So the way you're going to write that is def get full name, bracket self, pass for the moment, def get age self, and then pass. And guess what? That's our entire person class finished. We haven't coded it properly, but the setup is there. So, boys and girls, before we move on and set up our students and set up our teachers, how about I teach you how to use this thing?
That'd be good.
So we've created the idea of a person, but we're not doing anything with it at the moment. So what I want you to do, everybody, let's go down the bottom of our script here, press enter a couple of times and press backspace to make sure you're on the far left. We're no longer inside the class indent. And to make a person, okay, I'm just going to call it person1, just making up a variable name, equals person with brackets on the end. And congratulations, you have just made an object based on your class person. Now what the hell can I do with it? Well, oh my gosh. So I've created person1, let's put person1 and put a dot after it and have a look at all this stuff that pops up slowly on the projector. Date of birth, first name, get age, get full name, last name. Let's give him a name. First name equals Bobby. And then person1 dot last name equals, I'm really inventive with my names, Bob. And person1 dot date of birth equals date time. When can he be born, guys? Let's make him born in 1999. Oh, I shouldn't put quotes around that. Oh, what's month to your birthday, Adrian?
February.
February is 2. Okay, Dobby, what day is your birthday? 8, there we go. conglomerate. There you go, guys. So guys, we do have an error, and the error actually comes from line 6 on my screen. It's because we need to actually give date time a value. It's having a whinge. So who remembers what the epoch is? 1970-11. So that's like the earliest date you can possibly have in a date time. So why not use it? It's the default value usually, so let's just put that. Give it a go. If I press play now, nothing happens because I'm not printing, but I want you guys to print person 1 to the terminal. Tell me what it says. It's pretty awkward, isn't it? Okay, so what if you did print person 1 dot date of birth? Oh my god, print person 1 DOB.
Oh my god, it's a 0, 0, 0.
Hey, there's their birthday.
4, 9, 17.
8 to the 2nd, 1999. Absolutely spot on. Okay, what I reckon we should do, boys and girls, you can play around with this for a bit, but let's actually put some code inside of our get full name and our get age functions. So the way you do this, everybody, okay? Oh, no, you know what? One thing before we do that. Let's make a second person. Too bad. Person 2 equals person. All right, first name equals Jill. Jillianson. I've got amazing. Okay, there we go. We've made 2 person objects based on 1 class. And the really cool thing is, you write the code once and use as many times as you want. So everybody, come up to your functions with me. Let's go up to get full name. The way you're going to write this code, everybody, is we're going to return the full name back to whoever's using our person object. So what am I talking about? Literally type the word return for me. And somebody said before, but how do we make a full name? You plus them together. You take the first name and you add it to the last name, don't you? Put them together. So if I type in first name plus last name, I get some errors. Now, I'm going to scroll all the way up for a second. Everybody, the error here is because, remember how we have 1 class called person, but we can make as many objects as we like? Python is not sure which first name you want to use. Is it Bobby's or is it Jill's? Okay, the way we fix this is you put the word self in front of it. So it's self.first name and self.last name. So anytime you want to access an attribute, you simply put the word self dot in front of it. Inside your class. Nowhere else does self dot exist, really? All right. Now, how do we calculate the get age again, guys? Here's the awkward one. So yeah, we need the current year, take away the birth year. So if I do date time, brackets now, dot year, is it going to let me do dot year? Oh, okay, I'm going to have to do this a little bit later. Today equals now. Okay, and then we'll do age equals, and I'm just pulling these variables out of my head, by the way. Today dot year. Why am I can't access that? Ah, there it is. Brackets after now. Fantastic. All right, I'm just a goose. That's all it is, because I always forget. So date time dot now brackets dot year. Love each other later, guys. What'd you say? Sorry. Yeah, we do. Do I have to? No way. What? Oh my God, I'm having a mental breakdown at the moment. All right, there we go. I finally got there. All right, so we grab today's year. Then you subtract today's year from their date of birth year, and that should give you their rough age. Now that doesn't take into account like what day it is today and what day their birthday is or whatever. You can do that if you really want to. For simple example's sake, I reckon we just stick with that. Now, testing time. I'll give you a second to write this code down, but I want you to see if you can test the get full name and the get age functions for me. Methods, I should call them. So guys and gals, let's give it a quick test. I'm just going to focus on get full name. All right, if you want to follow me, I'm back down the bottom with our persons. So I'm just going to go print person1.get full name. And because get full name was a method, you must have brackets after it, but notice there's nothing in the brackets. Even though up here there's self, you don't have to put anything in the brackets. Press play. There's Bobby Bob. What's the problem with that though? There's no space. Oh my God.
Do you have to like plus blank?
You have to plus. Up here in the get full name, we literally need to do first name plus space plus last name. Otherwise, it literally is just jamming the names together. So we give that a shot. Bobby Bob, there it is.
So,
All right.
to the calculations
Yeah.
of the Visual Studio Code, Megatron and Optimus Prime are 40 years old.
Are they? Yeah.
Because I did the actual show, release date. Apparently it's 40 years old.
Is it really?
Yeah.
I used to watch that as a kid. That's insane. All right, I'm going to give this a go. Let's try get age as well. Person 1, get age. Bobby Bob is 25. That's legit. He was born in 99. 24 plus 1 is 25. There you go. So guys and gals, that's a person class 100% finished. We still have to do the student and the teacher, and we're going to do that in a second. All right, just quickly, there's a couple of concepts that I've introduced here that I want to quickly brush over, and then we're going to have a look at making the student and then making the teacher classes based on the person. First thing I want to quickly point to is this word return, okay? It's actually the most powerful thing you can create in a function. When you say return, what it means is someone has called this function. So get full name. What line of code down the bottom there is using get full name? Tell me the number.
21.
21. Absolutely spot on. So this line is the caller, because that's where they're calling from. Okay? Bit like a telephone, yeah? Then the code's going to jump up here. It's going to grab the first name, a space, and the last name, add those together, and then it's going to send it back or return it to the caller. Okay? So it goes back down here. This is now set to Bobby Bob. And what are we going to do with Bobby Bob? We are printing him to the terminal. Is that somewhat okay, everybody? So the other thing I love about this get age, look at, there's 3 lines of code instead of 1 now. You can do 50 lines of code in a method in a class. It's great to do that because now all of our code is up here inside the class rather than down here. Okay? So let's see how we can set up our other classes. Where's my Canva? So we have student down the bottom left and we have teacher down the bottom right. So how do we do this? I am just above my person 1 going to write class student, and before I put a colon in, I'm going to put brackets and then type in person. And this is how you set up inheritance inside Python. Okay, when you name your class, if you put something in brackets, it says whatever's in that class, it is now mine. Give it to me. Give me all the attributes, give me all the methods. I'm going to keep them. Now we've only got one attribute. That was finish year. So you're just going to put finish year equals 0 because it's an integer. And the function or the method get year, so def get year brackets self pass. Guess what? Student's done. If you want to write the code for it, get rid of the word pass and try it out. But you guys have got to do teacher as well. So go. Make a student, make a teacher, please.
I'm just getting out of the film, by the way.
I saw on the phone, so it's only very hot out.
Okay, boys and girls. There's student that I did in front of you before. There's how you would do a teacher one. See how you went. Okay, I want to move on in a second, and the next thing we're going to do is going to require a little bit of attention. So get this done. All right, guys and gals, kill those screens. put all of your attention strands back together for me, guys, and point up here. All right. Another concept that I haven't explained to you all. Pass. We kept putting that. We kept putting pass to basically say, I haven't written any code, don't bug me. These are called stubs, by the way. When you write a function and you don't put any code inside of it, but you want that function to exist, you simply put the word pass, and that says, Python, I'll do it later. Don't stress. Okay? And that is called a stub. And the great thing is, let's say Val and I are collaborating on a project, and I'm working on my class and I'm writing down all my attributes and all my methods, but I know for a fact I will not finish those methods. I simply put the word pass, and then when Val starts using my class, he can see the get year function, but then he'll also see there's no code written there. So he knows he can use it, and I will code it later for him. Does that make sense for you, everybody? It's basically like, it's a to-do list, essentially. I will get there eventually, but it's not finished, mate. Okay. So moving forward, I'm going to save that. We're going to close it. We're going to close it. We're going to close it. I would like to get started with the shapes program. However, we are going to start using GitHub for this project. Now, in the past, we've used Google Drive to back up all of our files, right? Okay, you just make a folder inside Google Drive, you save it, and all your changes are uploaded to the cloud. When you go home, you can download those changes and keep working, right? However, in the professional world, they rarely do that with coding projects. You do not put stuff on Google Drive. You might as a backup, like a last resort, but you will 99% of the time put it on what's called a Git service. And in this case, we're going to use GitHub because it's free. Students get all sorts of crazy perks and free stuff when you sign up. So what I want you guys and gals to do very soon is you're going to create your own GitHub login. At the top of the page, once you've logged in, there'll be a plus button to make a new what's called repository. Think of that as project. You're then going to call it shape calculator. You're going to make sure it's set to private. And then you're going to set what's called the git ignore to Python and then hit create. Okay, I'll leave this up on the screen. Can everyone jump onto github.com and do this now? I want to move on. So guys and gals, let me quickly explain what the hell GitHub is all about. So the first thing we're going to need to do is we're going to have to download that new project we just made on GitHub. Now that sounds weird because you just made a project and it's blank, right? Good. You want a blank project. So we're going to use the GitHub desktop app, and we're going to use this to log into our account. So you first of all need to make sure when you first open it, it's going to go, oi, you need to log in, mate. So just make sure you do that first, please. Once you've logged in, you're then going to search for your shapes calculator or any other stupid name you might have given your repository because you didn't listen to the teacher and just wrote your own thing. Okay? You will then choose the clone option here, and it's going to come up with a bunch of options. Now, this is the bit that I reckon is going to catch some people. So hopefully when I explain it, it doesn't. So can you make sure you search for your shapes calculator after you've logged in? When this comes up, make sure you set this to your Google Drive, this local path, because what it has to do is it has to make a folder and it has to put a bunch of little things in that folder. And why don't we just keep using Google Drive? That way everything is safe and we're never ever going to lose anything. And when you hit clone, you'll have the project on your Google Drive and you can literally see there'll be a button that says open in Visual Studio Code. Is everyone okay with those steps? So look for the app on your desktop, literally called GitHub Desktop. Open that up, log in, and you should be able to search for your project on the left-hand side. So let's go. If you need help, let me know.